Okay. All right. That video is taking a billion years to export, so I'm going to do one little quick thing here. Let's try and make this show a little bit better. Um, let's try and add some annotations here. Let's say, for example, that if we came back here and I wanted to for example, have if this prints out Jesus. There we go. All right, let's say, for example, I wanted this to be like first name equals, right? What we can do is we can use annotations to do that. I can come down here. I copied this. I cheated a little bit. This is a template you can use in order if you just want to have like a simple class that has a name. I will note, this is very important. Red flag, red flag. If you do this, it's very common to use lowercase names for annotations. Um, these need to be in quotes here like this. And some of these might be redundant. I just kind of wanted to go crazy to make sure it would match on anything. Um, these need to be in these backticks because there's something hard coded in the compiler to treat underscore names as or under or lowercase first letter classes as like identifiers instead of classes or something like that. So it thinks that a constructor can't exist. So little bug, compiler, maybe they fix it by now, who knows? But you gotta have the backticks. And so this is the from expr that I talked about in the first video. And so what this lets us do is essentially if we have an expression of this field name, it lets us get an actual instance of the field name. And so this is useful because when the compiler or like when our macro pulls an annotation, it's actually going to be a term, which is the kind of erased type version of an expression, the expr. So this is going to we need a way to go from this expr of field name to a field name. So this from expression is exactly how we do that. So that's all to say I've added this field name. And so now if I go here and I go at field name, I should be able to go at first name, boom, and then I run this again and it's just going to magically work without doing anything else. Just kidding. I lied. We have to actually program it, sadly. So what we're going to do is it's going to be really easy. So here we're doing expr field.name. What we can do is field.annotations. We want this optional of value here is what we want. And this is essentially, there's a bunch of different versions of these. All the different types like case or product generic, sum generic, field, all of these have the ability to get these annotations. And there's different things. Like we can get all terms. We can get all of a certain type. And do all of a certain type. Optional of. These all, notice how these are returning an expression. But we don't want an expression. We want the actual value. So there's a required of value. We want the optional of, because we don't want to force you to put this annotation on every field. So if you supply it, we want this. And it's essentially going to enforce that if you use this optional of value as opposed to optional of, it your from expert needs to pass. So if for whatever reason you apply an annotation that's of this field type that doesn't look like one of the expressions that's expected um, here, it's just going to fail. So what we can do is we get this optional of value here, and you can see that this is an option of field name. And so what we can do is we can fold here, and we can do field name or that, and that should be literally all we need to plug this annotation in. Oh, don't trust the compiler. Don't trust it. You got to reload it from here. I'm assuming it's working. Amazing. It worked. I was right. Okay. First name. Cool. Awesome. What's another thing we can do? Let's go and let's add another one. Class here. Let's say we want the ability to hide what's in a certain field. That sounds real. Sounds like something we might want to do. One day I'll figure out what the actual required things to do this here are, but we're just going to overdo it for now. And let me go. Now what do we got here? Oh, that helps. Okay, amazing. Now we've got our from expressor for obfuscate, and let's go and let's say, ooh, should never ask someone's age. Let's obfuscate that. All right. Obviously here, we run it again. It's not going to do anything. But let's just see that it still works and nothing's broken. Awesome. And let's go here. Let's go show expression. It's going to be an expression of string. And for right now, we're just going to set this here. Boom. I'll still be compiling. Oh, it hates me. Why does it hate me? Oops, because I put that higher than it should. Awesome. Okay. So now we have same thing as before. We just have pulled this out so we can play with it. And now let's do this. If same thing, field dot annotations dot optional of value obfuscate. So if it's not empty, or we'll do this base. So if this is non-empty, what we're going to do is base, and then we're going to map it and go like this. Boom. Everything is a star now. else we'll just do base. Base. Oop, I'm silly. That needs to be that. Awesome. Okay, and now let's see what happens. Oh, it's not going to do anything because I didn't run this file probably. Oh, it worked first try. There we go. Awesome. So now we've just hidden what's in this field. So annotations, very useful. You don't always need to use the of value. It's pretty much useless the fact that I did of value here, because I didn't actually use what the value that was extracted. I just checked if it was there or not. So I could literally do this and it would behave exactly the same. Yeah, annotations are fun. You can do lots of cool things. Maybe in a future video we'll get more into what you can do with them. But for now, that's a nice short one on how you can use annotations to affect your type class derivation. Catch you in the next one, where we'll actually talk about E, probably.